So we don't know it, so...
Yeah, so let's do this one first. We'll do it in order. So we have our... So we have our CO2, which we determined is molecular. We have our NaCl, and then we have our iron oxide guy. We determined he's ionic, and he's ionic, right? Okay, so molecular is when we use those numerical prefixes, because we're very specific in how many of each. Because this is different than that, right? So for moleculars, we state the names, and we end with an "ide" at the end for the anion, or the oxide gets an "ide." So how many carbons do we have? One. And so if the first guy it has only one, we just don't put mono in front of it. We just write out its name.
So when you use mono when you're talking about molecular, but what you said since... Oh, it's the second one though, it's the mono, not the first. Okay.
Yeah, because it's just repetitive.
Okay.
We only add one in the beginning if it has more than one.
Okay.
So carbon, how many oxygens?
Dioxide.
Yeah.
Two.
Dioxide. And we just ended in an "ide," so it's a molecule.
So you use this when using molecular, so metal to metal. No, non-metal to metal. No, non-metal to non-metal?
Yep. All non-metals.
Okay. So I wonder if I can find...
Yeah. Okay, I want to do this one.
Yeah.
Here's NaCl. We know it's ionic, and so with ionics, we state the cation's name, and we determine if we know its charge or not. So what's the cation's name?
Sodium.
Do we know sodium's charge off the periodic table?
Yes.
Yes, that means we don't need parentheses. We use parentheses with transitional metals because the transitional metals have multiple playing cards, and I don't know which card they just put down. With these guys, the ones that we know what their charge is. They always play the same card. We don't need to put parentheses. It's if he puts down his card, I know he's playing.
Okay.
And so sodium, and then we state the anion's name with an "ide" at the end.
So chloride.
Yep, sodium chloride. Okay, we determined this one's ionic, right? So we state the cation's name, who is?
Iron.
Yep. Do we know his charge off the periodic table? No, means we need to figure it out. So we can use his buddies to help us. Oxygen has what charge?
-2.
Yeah. And since there's one of them, overall -2 on that side means we need a +2. Since there's one of them, he gets a +2. Alright?
Okay.
And so this is what we represent in parentheses.
Oh, okay. I was gonna ask you about those. I didn't understand
That
what
meant
the parentheses meant.
he has a 2 charge,
Okay.
+2 charge. And now we state the other guy's name with an "ide" at the end.
So oxide.
Yep. Iron 2 oxide.
Okay.
Because if this was, I could also, another form is this. However, this time, since there's 2 and each one has a -2, this has a 4 negative, so that's a 4 positive, and there's one of them. So this time he's 4 positive. So he would be written iron, or actually, yeah, that kind of thing. It's different. Oxide. Or we can also do it with iron 2O3. And each one of those has a 2 negative, right? So 6 negative, 6 positive. Since there's 2 of them, I split it up. So they each have a 3 positive. So this time it's iron 3 oxide. And these all represent different molecules.
Okay. That makes no sense. I was wondering where they got Roman numerals from, and I didn't quite understand why.
Yeah. Multiple playing cards. Which card is he playing this time?
Okay. So like in this one here on Alex, so magnesium and oxygen. Magnesium is, let's see, metal, and oxygen isn't. So then that would form an ionic compound.
Yep.
So then the empirical formula, you put the magnesium first and then oxygen. But magnesium has, let's see, +2 and oxygen has -2, so it means they're happy. So
Yep.
just MgO. So then the name of the compounds, instead of just looking for ionic naming, so it'd be magnesium oxide.
Yep, because we know magnesium's charge. So we don't have to put parentheses. Yeah, magnesium oxide.
So then barium and rubidium or whatever, they're both on the same side, so they don't form.
Yep, barium.
So they'd be molecular instead. No, it
No.
wouldn't be anything because they're not, they're metals.
Yeah, they're both metals. Metals don't bond to each other. They're not happy. And at least these binary compounds, when there's just two of them.
So then bromine and that would, so whatever that, I don't know how to say
So you
that.
said rubidium or whatever?
Rubidium, yeah, so
Like
that would come
RB or
first.
something?
Yeah.
And
So
then,
rubidium, and then that's positive, and bromine is a negative, so they're happy just by themselves. So then it was rubidium bromide.
mhm. Yeah, and we know rubidium's charge. Oh, they like them lowercase, just to you know. I don't know if they like it after you or anything, but they just like them all lowercase. I like them
Trying
uppercase,
to
but
use proper grammar.
you give Alex what Alex wants.
So then magnesium, bromine, they do. So then the magnesium has 2, but bromine has 1.
Yeah,
So then bromine needs 2.
yeah, you got it.
So that'd be MgBr2.
And we know magnesium's charge, right? So we don't need parentheses.
So then, can I get some of these examples?
Yeah, we can go through those if you want. Identify them as ionic, molecular, or acids.
So the acid is one that has an H in front of it, right? So,
Except for water, right?
because yeah, water's an element. So S3Cl2. So sulfur, and then they're both nonmetals, so then
Yeah.
they're molecular. So then they would be named, let's see, 3 trisulfur dichloride.
Yep. Precisely.
So how do you know, do you just name it with the dye at the end? Is that just because they all, actually they all in I, right? When you're doing this, okay.
Except for the acids.
Okay. So then magnesium, parentheses, N3. So then magnesium is a metal, and then nitrogen oxide. So
Not nitrogen
they're-
oxide.
But
Who
they're
is he?
nitrate.
Nitrate, yeah.
So when you're using polyatomic ions like that, how do you know?
Well, just look at these right now because we're trying to name it overall. You know, he's nitrate, right?
Nitrate, yeah, so that's a non-metal.
Yep, non-metal, non-metal, metal.
So then it's going to be an ionic compound.
Yeah.
So then would you just name it magnesium nitrate? Okay.
You can write those things down if you want.